Hello and welcome to Science Talk. I am your host, Jim Massa. A couple stories for you here. One involves the discovery of organic molecules that helps explain the infrared glow that is pervasive throughout the universe. So, the universe is filled with faintly glowing infrared light, and it's found out to be emitted by an organic molecule called benzonitrile. Benzo refers, of course, to the benzene ring, which is what's called an aromatic hydrocarbon. Aromatic not in the sense of giving off an odor, but more in the sense of its ring-like nature. And nitrile is basically a nitrogen-containing group. The researchers presented their findings at the 231st meeting of the American Astronomical Society. Benzonitrile belongs to a class of molecules known as polycyclic aromatic hydrocarbons, as I just alluded to. Using new data from the Green Bank Telescope located in West Virginia, astronomers have noted for the first time the convincing radio fingerprints of a close cousin and chemical precursor to PAHs. PAHs are polycyclic aromatic hydrocarbons. And this molecule, of course, is the benzonitrile that has been identified. Okay. Researchers at the National Radio Astronomy Observatory in Charlottesville, Virginia, are the ones who have done this study. NRAO, that's National Radio Astronomy Observatory, astrochemist Brett McGuire is the lead scientist. How did they find this molecule? They discovered using a telescope that measures radio waves. Radio waves is really part of the electromagnetic spectrum. The so-called visible light that our eyes can detect fall within a very narrow range of frequencies among the entire electromagnetic spectrum. Radio waves are some of the longer waves out there, as are infrared. You go to the other end and you have ultraviolet rays, X-rays of very short wavelengths. So they all occupy different frequencies of the electromagnetic spectrum. McGuire and his team were using the GBT. This is a radio telescope that has a 328-foot dish. That's longer than a football field. And this telescope looked at the radio spectrum coming from the Taurus molecular cloud, which is a star-forming nebula located approximately 430 light years from Earth. In making their observations, they saw spikes in their data indicating the presence of benzonitrile. Elements, compounds, tend to have their own unique signature when they are excited, when you are looking at spectrums and so forth. For example, if we looked at a mass spectrometer, how does a mass spectrometer detect whatever's present in the compound being analyzed? It's looking for telltale spikes at certain frequencies, certain locations, which then identify whatever that is as being that compound. The same idea here. So that's so basically they're finding this benzonitrile as giving a infrared glow to the universe, which of course we can't detect. This is different than the background radiation that's left over from the Big Bang. That's the background radiation left over from the Big Bang is in a completely different location on the EM spectrum. The next story I wish to share with you is as follows. Earth resides in an oddball solar system. Our solar system, according to the study here, may be an oddball in the universe. A new study using data from NASA's Kepler Space Telescope shows that in most cases, exoplanets orbiting the same star have similar sizes and regular spacing between their orbits. Kepler is the satellite that is detecting exoplanets. When you consider what they've been finding contrasted to our solar system, we have the so-called inner rocky planets, then we have the outer gas giants. Well, according to what these researchers are saying, our solar system may be the odd one present. When you think about it, we have Mercury, which is about approximately a third the size of Earth, and is considered to be pretty much a metallic body. And then we have Jupiter, which is, what, 11, 12 times the diameter of Earth, something like that. In fact, Jupiter came very close to becoming a star of its own right. It's about an order of magnitude from doing so. I guess that's what the movie 2010 was all about. But if that was the case, then we could have easily have developed a binary star system here. But Jupiter did not get additional mass and did not have sufficient gravity to start forming its own thermonuclear reaction inside its center. So if that's the case, if our solar system is different from other solar systems of what has been observed, then that seems to have the implication that perhaps our solar system formed differently. Okay. The scientist who led this study is Lauren Weiss. She is an astrophysicist at the University of Montreal. And this is what she stated: the planets in the system tend to be the same size and regularly spaced, and she used the analogy like peas in a pod. These patterns would not occur if the planet sizes or spacings were drawn at random. Different sized planets are going to sweep out different areas, have a changing gravitational effects. Jupiter is going to have more of a gravitational effect than, say, Mercury or Venus would around it. So Jupiter can keep objects further away from it, creating a larger space around it, whereas Mercury cannot. It's kind of what she's getting at. If you have planets of the same size, then due to gravitational forces, they're kind of going to regularly space themselves apart rather uniformly. So her research team looked at 355 stars that had a total of 909 planets. Okay. These planets would periodically transit across the face of the stars, hence we can make in our observations of them. The planets on average were between 1,000 and 4,000 light years from Earth. They ran a statistical analysis. They found that a system with a small planet would tend to have other small planets nearby, and vice versa. Big planets tend to have big neighbors. And as I noted before, these extrasolar systems also had regular orbital spacing between the planets. Researchers go on, and Dr. Weiss goes on to state, the similar sizes and orbital spacing of planets have implications for how most planetary systems form. In classic planet formation theory, planets form in the protoplanetary disk that surrounds a newly formed star. Basically your dust cloud that you probably are familiar with. The planets might form in compact configurations with similar sizes and a regular orbital spacing in a manner similar to the newly observed pattern in exoplanetary systems. Our own solar system is very different. As we noted before, we have the rocky inner planets and the outer gas planets. Each of the exoplanets examined in the study was originally found by Kepler. Dr. Weiss basically says that they're going to plan a follow-up study at Keck to look for Jupiter-like planets in multi-planet systems. Basically, they want to see if they can get a better understanding of planetary formation dynamics and just to learn more about that. So it could very well be that our solar system is unique. It could also very well be that the technology has enabled the astrophysicists to detect what they've detected so far. Perhaps with better refinement, they might discover a solar system with differing sized planets. They may even find, when they revisit some of the solar systems they've looked at, that with refined techniques, they may indeed go back and say, oh, there are planets of differing sizes. Like everything else in science, everything is ongoing, and gather new information, new data to support or revise current thinking. That brings me to the end of this video. I want to thank you for watching. If you are not a subscriber to my Patreon page, I hope you will consider doing so. For those of you who are subscribing to my Patreon page, I thank you. Please go to patreon.com/Science Talk with Jim Massa and support the work we do. I publish other materials solely on Patreon, solely for my subscribers. I publish stories that go into more detail. I publish feature stories. For example, I will publish stories on scientists, on specific topics. Example, evolution, the conveyor belt, and other topics that I wish to share with you. So you get much more content on Patreon, and that is for my subscribers. Thank you for your time. Tell others of the work, and we'll talk soon.